Hello there, this is Ms. Nakayama. Today's lesson is 4.8 Applications of Trig Functions. We are going to talk about solving right triangles and then solving problems involving bearings. That might be something new, but we'll go over it. So first and foremost, solving right triangles means to find any of the missing sides or angles. And since we are talking about right triangles in this lesson, we will be using what you're familiar with, which is SOHCAHTOA, standing for sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's what we're going to use when we solve our problems. So first and foremost, I have A, big A. Remember, capital letters represent angles. Small letters represent the sides opposite those angles. So big A is, angle A is 62.7 degrees. Little the side opposite is 8.4. And they want us to solve this right triangle, rounding links to two decimal places. So first and foremost, I like to set up what I need to know. It'll tell you in MyLab Math. So we have to find angle B, we have to find little b, and we have to find little c. Okay, so to find b, we know that angle C is 90 degrees. And in all of these problems, y'all, it's a right triangle, so one angle is 90. That means to find the other two have to add up to 90. So that means that angle B is just going to be 90 minus 62.7, which is 27.3. Okay, next, I just have it set up to go for little b. It does not matter the order that you do this in. But if I'm looking for little b, notice that little b is in regards to angle A, because that's what they gave me. You always want to use the information they gave you, that it is opposite. And little a, of course, I'm sorry, that's not opposite, y'all. This is adjacent to angle A, and this is opposite angle A. So that trig function is, of course, tangent. So the tangent of 62.7 is opposite, which is 8.4, over adjacent, which is little b. So when we have talked about solving this type of problem before, y'all, a lot of times people, if you multiply both sides by b, the b comes over in front of the tangent. It's not by itself. So then you would have to divide. So when I'm solving these problems, I'm going to tell you every time you solve them, you either multiply or you switch them. So if b, my variable, is on the bottom, I just have to switch these two, just combining two steps in one. So that means that b is going to be equal to 8.4 divided by the tangent of 62.7, and that is equal to 4.34. Now, excuse me, if I want to go to C, C, of course, is my hypotenuse. And if I'm going to use what I'm given, okay, so that means I'm going to use this number and this number. That means I'm dealing with opposite and hypotenuse, so that's my sine function, the sine of 62.7. Opposite is 8.4. Hypotenuse is C. My variable's on the bottom. I'm going to switch those two, so C equals 8.4 divided by the sine of 62.7. Make sure your calculator's in degrees, and your answer is 9.45. And that's all we have to solve. Okay, next one, more of an application, real-world problem. From a point on level ground, 80 feet from the base of the Eiffel Tower, the angle of elevation, that's when we're looking up, is 85.4 degrees. Approximate the height of the Eiffel Tower to the nearest foot. So my angle is 85.4. 80 represents the side adjacent. I didn't want that. I want this, the side adjacent. And A is the side opposite. So again, I'm dealing with the tangent function. So the tangent of 85.4 is opposite, which is A, over adjacent, which is 80. This time my variable's on top, so I can just multiply those two together, and I get that A is 999 994.31 rounded to the nearest foot is 994 feet. Okay, look at this guy. A guy wire is 13.8 yards long and is attached from the ground to a pole 6.7 yards above the ground. Find the angle to the nearest 10th degree that the wire makes with the ground. So, you obviously, the best way to handle this, y'all, is to draw a picture. The last two problems we had a picture. So you want to start off with drawing a picture. We have a right angle, okay? A guy wire is attached to a pole. So I hope y'all can tell that my pole is going to be vertical to the ground. So it's 6.7 yards. The guy wire is not already on the ground. It's attached from the pole to the ground. So that means this represents my guy wire, excuse me, that is 13.8 yards long. Find the angle. So I'm looking for theta to the nearest 10th of a degree. So again, angle theta, 6.7 is opposite angle theta. 13.8 is the hypotenuse because it's opposite my right angle. And that's going to give us opposite hypotenuse is the sine function. So sine of theta is 6.7 over 13.8. When I'm looking for the angle, so I'm going to solve this for theta. When I'm looking for the angle, I write it this way because it helps me remember which button on the calculator I need. So theta equals 29.046, and that gives me an answer to the nearest degree of 29 degrees. All right, another one, probably challenging for some, but not too bad. Find the length of x to the nearest whole number. So when you look at this problem, y'all, this particular triangle right here that x is a side of is not a right triangle. So you've got to do something with a right triangle first. So that means I'm going to solve this little triangle, and I'm just going to label this side A. It doesn't matter what you use. But I have 66 degrees, and I have 310, which is opposite, and A, which is adjacent. So I'm going to use the tangent of 66 being opposite, which is 310, over adjacent, which is the letter A. Variables on the bottom, I got to switch those. So A is 310 over the tangent of 66. Put it in my calculator, and I get that A is 138.02. So from here, I'm now going to look at the whole triangle and think about this whole side. So I'm going to use tangent again, the tangent of 39. Opposite is 310, but this time my adjacent is 138.02 plus x. Again, my variable's in the bottom, so I'm going to switch these so it looks like that. So when I take 310 divided by the tangent of 39, I'm going to get 382.82. I'm now going to subtract 138.02 and find out that x is equal to 244.8. And rounded to the nearest whole number is going to give me 245. Okay, the other thing we have to talk about here is something called bearings. And bearings is what is used in navigation and land surveying, navigation being ships and airplanes. And this is how they describe their location as opposed to a coordinate plane. So what you need to know is a bearing is an acute angle measured in degrees between the north and south line. And each bearing has three parts. You have a letter first, which is going to be north or south, the measure of the acute angle, and then you're going to have another letter, which is going to be east or west. So look at these examples. Okay, this first one here, it's above the x-axis, so that's why we're using north. It's measured 65 degrees from north, and it goes to the left, which is west. So this is read 65 degrees west of north. This one is an example of 40 degrees east of north. Oh, and this one is, 70 degrees east of south because it's below the x-axis. Okay, 2 examples to try really quick, and then we're going to do a problem, and then we're done. So the bearing from O to D is this point right here. So it is using the south line because it's below the x-axis. So I'm going to start off with the letter S, and then I have the angle measured from the vertical, which is 25 degrees, and it goes towards the east. So my answer looks like that. If I want to go from O to C, again, I'm going to be using south, but the angle always has to be measured from the vertical. So I've got to figure out what this angle is, which it's 90 minus 75. So it's 15 degrees, and it goes towards the west. So that's what that looks like. All right, last problem. A forest ranger sights a fire directly to the south. A second ranger, 8 miles east of the first ranger, also sights the fire. The bearing from the second ranger to the fire is 21 degrees west of south. How far is the first ranger from the fire? So I'm not an artist. I'm just roughly sketching the fire down here. And I have a forest ranger sees this is the first forest ranger because the fire is directly south of him. Then he has another ranger that is 8 miles to the east who also sights the fire. And the bearing from this second ranger is 21 degrees west of south. So if you think of your little compass or your north and south here, and you're thinking about his viewing angle that he's coming from, you have to measure this angle right here as 21 degrees. That is 21 degrees west of south. Now, in my triangle, I know that this angle right here is 90 degrees. So 90 minus 21 is going to give me my 69. How far is the first ranger from the fire means I'm looking for that length right there. So I have 69, I have 8, and I have x. X is opposite, 8 is adjacent. So I'm going to use my tangent. Opposite is x, adjacent is 8. My variables on the top, I get to just multiply those two together, and I get that x is 20.8, and so it's 20.8 miles. And that is all we have for applications of trig functions. Thank you so much for watching, and y'all have a great day.